Assalamu alaikum and very good morning dear students. This is our video lesson 15 and this lesson is for chapter 20. Chapter 20 is Axioms, Postulates and Propositions, and topics are demonstrative geometry, axioms, postulates or theorems based on lines, angles and triangles. Dear students, please open your mathematics books. New countdown, book 8. By the end of this lesson, you should be able to define demonstrative geometry and reasoning, describe axioms and postulates, and prove theorems based on lines, angles, parallel lines, and triangles. Demonstrative geometry. The word geometry comes from the ancient Greek word geo, meaning earth, and metron, meaning measurement. Geometry is present all around us. It is part of nature. We observe geometrical shapes, facts, and phenomena as concentric circles formed by dropping stone in pool. You must experience this. Sometimes if you see still water and you throw a stone, so we see a continuous circles are forming. So those are called concentric circles. Shapes of sun and full moon are circular. Angles are formed every time when a door is opened or shut. You can notice the angles formed by door and floor, or sometimes door and wall, or between two parts of the door. And shape of pyramids of Egypt. Cans, bottles and some containers are cylindrical in shape. Humans, animals and leaves and flowers and so many things are symmetrical in shape in nature or in our environment. Axioms, postulates and propositions. Geometry is deductive science. The general statements are used to derive specific conclusions about some concepts. The basic principles as sum of angles of triangle is 180 degree leads to fundamental statement. It's like triangle ABC and triangle XYZ each has angles add up to 180 degree. So this is a type of fundamental statement. An axiom is fundamental statement that related to numbers. A postulate is a fundamental statement that is related to a geometrical figure. A proposition or theorem is a statement that is developed on the basis of postulates and axioms. A corollary is a statement that is deduced from a proposition or theorem. Now, propositions or theorem. Procedure to prove theorem. First of all, write the theorem, then draw the shape according to theorem, write the given data, and write the statement which is required to be proved. Additional construction if required. Sometimes we need some extra construction to prove a theorem. Proof with reason. Now, first example is, the theorem is if two straight lines intersect, the vertically opposite angles are equal. We will form two straight lines which are intersecting each other. The lines are XY and PQ and they are intersecting at point O. Now, measurement of XOQ plus measurement of QOY is equals to 180 degree. XOQ and QOY, because they are on a straight line. So obviously their sum is 180 degree. They are supplementary to each other, so their sum is 180 degree. And you can say they are on a straight line, so their sum is 180 degree. Now, measurement of XOQ plus measurement of QOY is equals to measurement of QOY plus measurement of YOP, as measurement of XOQ and QOY and QOY and YOP. They are also on a straight line, so their sum is also 180 degree. So this part is common. QOY is common. It means these two angles are same. So it is proved. And the same is with XOP and QOY. In the same way we can prove that these two are also similar or congruent. Now, corollary of the theorem. The following corollaries can be extended from the previous theorem. Corollary 1. When two lines intersect, the sum of the four angles thus formed is equal to four right angles. Corollary 2. If any number of straight lines meet at a point, the sum of all the angles thus formed is equal to 4 right angles. So basic rule is same, but we can use different theorems or different words to prove that. Now another example, if a straight line stands on another straight line, the sum of sizes of the two angles formed is equal to 180 degree. This is almost same as the previous theorem, but in a little different way. They are saying if a straight line stands on another straight line. So this is straight line and one line is standing on it. So the sum of their angles or sum of these angles is equal to 180 degree. Obviously if these are on a straight line, so their sum is 180 degree. So measurement of angle AOC plus measurement of angle BOC, AOC and BOC, it is equals to AOB. The angle is AOB, which is a straight angle. So the straight angle is equals to 180 degree. So it means their sum is also 180 degree. So the theorem is proved. Now another example, the sum of the measures of the angles in a triangle is 180 degree. How do we prove it? Now measurement of angle B is equals to measurement of angle 1. See this is extra construction which we have done. The angle was given and we just had to prove that these three angles are same. The sum of these three angles is 180 degree, and we do this extra to prove why their sum is 180 degree. So now this is 1 is equals to B because they are alternate angles and they are congruent. Then angle C is equals to angle 2 because these are also alternate angles. This is a one line and this line is parallel to this, so they are making alternate angles. So these are congruent, we know this. And so adding 1 and 2, angle B plus angle C and plus angle BAC, like BAC, so this angle, so they are equals to 180 degree. Why? Because they are on a straight line. So angle 1 plus this angle plus angle 2, they are making 180 degree. And angle 1 is like same as this, angle 2 is same as this. So it means the sum of these three angles is also 180 degree. So now again the theorem is proved. Now theorem and its converse. The first theorem is when a transversal intersects a pair of parallel lines, the alternate angles formed are congruent. So the base is that the lines are parallel and they are making alternate angles, so these are congruent. We have to prove this. The basis lines are parallel, and its converse is saying when a transversal intersects two lines such that the pair of alternate angles are congruent, the lines are parallel. Here first they are telling that these angles are congruent, so then it is obvious that these lines are parallel. So these are opposite to each other or converse to each other. Now theorem and its converse. The converse of the theorem is created by using the conclusion of the original theorem as the hypothesis of the converse. The hypothesis of the original theorem becomes the conclusion of converse. So these are opposite to each other. Now summary of today's lesson. What we learned today: demonstrative geometry and reasoning, axioms and postulates, theorems based on lines, angles, parallel lines and triangles. Now the last part of our today's lesson, which is written assignments. Your task 1 is question number 1 to 3, exercise 20, page 236 of new countdown 8. Your task 2 is question number 4 to 6, exercise 20, page 236. Your task 3 is question number 7 to 9, exercise 20, page 237. Your task 4 is question number 10 and 11, exercise 20, page 237. And your last task is question number 12 to 14, exercise 20, page 238 of new countdown 8. I hope you enjoyed today's lesson. Allah Hafiz and keep practicing.